Our NIC AAT presentation. Our group includes Anirudh, myself, that's Arnav, and Channa on our topic. Our topic is Greywolf optimization algorithm. The table of contents include introduction, meta-heuristics, the Greywolf pack structure, the social hierarchy, the hunting mechanism, mathematical model, pseudocode, flowchart, numerical advantages, and then conclusion. Let's start with introduction. What is optimization? Optimization is the process of finding the best possible solution under given constraints. It's fundamental to engineering, design, economic planning, resource allocation, and countless real-world applications where efficiency and effectiveness matter. Meta-heuristics is another gradient of the same, where traditional methods often struggle with complex high-dimensional problems. Meta-heuristics provide with powerful alternatives that navigate vast solutions and efficient finding near optimal solutions where exact methods would fail or take prohibitively long. We use meta-heuristics because real-world problems often include many variables and are non-linear. The exact methods that computationally expensive and get stuck in local optima. Meta-heuristics like Greywolf optimization, balance exploration, and exploitation. Some of the popular meta-heuristics algorithms include genetic algorithms, particle sum optimization, ant colony optimization, and Greywolf optimization. So let's start with Greywolf optimization. Greywolf optimization includes it's a nature-inspired algorithm based on leadership, hierarchy, and hunting behavior of grey wolves. The social structure of Greywolf is a important criteria in this. The Greywolf live in packs and often maintain a strict social hierarchy, which helps them to hunt. This hierarchy isn't about dominance; it's about sophisticated system of cooperation and decision making. Their hunting strategy, the wolves employ a three-phase cooperative hunting strategy: tracking prey movements, encircling to cut off escape routes, and attacking as a coordinated team. This teamwork models solution convergence in Greywolf optimization. To understand the social hierarchy in Greywolf optimization more, we look at the different ranks in Greywolves. The first is Alpha, the leader, represents the best candidate solution found so far, guiding the entire search process towards optimal regions of the solution space. Beta, the second best solution that supports Alpha and helps in decision making, providing alternative directions for the search. Delta, the third solution that assists in refining the search, maintaining diversity in the solution pool. And Omega includes the rest of the pack, which is the lowest rank of the wolf pack. They follow what everyone else says. This hierarchical structure creates a powerful balance between leadership and diversity, preventing premature convergence while maintaining search efficiency. Their hunting mechanism is derived from this social structure, wherein they first encircle the prey and update the position relative to the best position solutions, that is Alpha, Beta, and Delta, which surrounds the prey. Hunting phase, Alpha, Beta, and Delta estimate prey location, guide the pack towards the optimal solution, and through coordinated movement, attack the prey. Wolves converge on the best solution, intensifying local search and exploitation to refine the answer. Also, wolves explore new areas to discover better solution and avoid getting trapped in local optima. What you see right now is the social hierarchical order, and it includes different characteristics of the different layers. Like Alpha is responsible for decision making, Beta is responsible to help Alpha in better decision making. Delta is the scapegoat of the group and have to submit to all the other dominant wolves. Omega is basically the herds that listen to the Alpha, Beta, and Delta. They're responsible for watching the territory and protect and guarantee the safety of the pack. Thank you. Now Channa in our group will continue with the mathematical model.
Now let's let's explain the working principle behind the Grey Wolf optimization algorithm, an algorithm where technique inspired by social hierarchy and hunting strategies of Grey Wolf in nature. To begin with the hunting mechanism, Grey Wolves follow a coordinate strategy that transitions smoothly from exploration to exploitation. In nature, wolves first search for prey, then encircle it, proceed to the hunting phase, and finally attack the prey. Similarly, in the algorithm, wolves explore the search space to find the promising regions, then converge towards the best possible solution. The social hierarchy of the wolf plays a central role too. The pack is led by the alpha wolf, which is responsible for decision making but isn't necessarily the strongest one, just the best at managing pack. Next is the beta, the advisor to the alpha and the most likely candidate to replace it. Below them is the delta, which handles the tasks like protecting the pack, acting as a messenger, and supporting the dominant wolf. Finally, the omega plays the role of a scapegoat but also helps in maintaining the balance of the pack. In Grey Wolf optimization, the alpha, beta, and delta are represented as the top best solutions, and the rest of the wolves follow these during the search process. Now, let's move on the mathematical model of Grey Wolf optimization technique. The position of each wolf is updated by considering the position of alpha, beta, and delta. The new positions are essentially the average of three calculated vectors, each influenced by one of the top wolves. The guide To guide the wolves, the movement the algorithm uses adaptive coefficients of A and C. Coefficient A determines whether the algorithm emphasizes on exploration or exploitation, while C introduces randomness to prevent premature conversion. The crucial part of the algorithm is linear decrease strategy, where parameter A decreases linearly from 2 to 0 across iterations. This ensures that algorithm focuses on exploration at the beginning and shifts to exploitation in its progress. Looking at the pseudocode of this algorithm, we start by initializing the wolf population along with the parameter A and C. We calculate the fitness of all wolves and indicate the alpha, beta, and delta. Then, for each iteration, every wolf updates its position based on the three leaders. After updating positions, we recompute fitness, update the hierarchy, and continue until maximum number of iterations is reached. Finally, the alpha wolf representing the best solution is returned. Looking at the flowchart, this is what it looks like. Initializing the parameters is the first step, followed by generating the population, evaluation of fitness, identifying alpha, beta, and delta, updating positions, adjust control parameters, recalculating the fitness, and repeat the whole process until the conditions are met. In summary, the Grey Wolf optimization algorithm mimics the leadership hierarchy and the hunting strategy of grey wolves to balance the exploration and exploitation, ultimately converging towards the optimal solution.
Uses the step-by-step procedure for performing a numerical example of Greywolf optimization. It explains what happens in each iteration of the algorithm. First, we initialize the parameters, decide the population size, that is the number of pulls, and set the maximum number of iterations. And we find the best three wolves, that is X alpha, best solution, and X beta and X delta. For each iteration, we compute the parameter A using the formula A is equal to 2 into 1 minus iteration by max iteration. Compute x1, x2, x3, which represent the three encircling position vectors. Then compute the new wolf position by x new is equal to x1 plus x2 till xn by n. Check the bounds, stay inside the search limits. Then apply greedy selection. If new position is better, update the wolf's position. Now let's look into the numerical where we have given that to minimize the objective function where the bounds are between -5 and +5 and the population size is 5 and number of iterations is 200. The initial wolf positions are given and we find the fitness value of each of the position wolf. The wolf which has the least fitness value is considered as the best. that is the ranking of the wolves are wolf 2, wolf 3 and wolf 1. Now we compute the value of A, we get 1.99. This shows that at iteration 1, exploration is still very high. Now we compute the new wolf position using the formula, and then we update the position after first iteration. After all the iteration, the which position of the wolf gives the least fitness value is considered. Advantages of Grey Wolf optimization is very simple to implement, which has very few parameters and easy to code. It has efficient global search, great balance between exploration and exploitation, competitive performance, often outperforms other algorithms like genetic algorithm and particle swarm optimization. It has a very wide range of applications used in feature selection, structural design, scheduling, image processing, power systems, and machine learning optimizations. Why Grey Wolf optimization matters? Because it is the nature's wisdom, as it is inspired by the real world hunting strategy of wolves. It is a powerful metaphor. Leadership hierarchy gives an intuitive, reliable optimization system. Practical excellence with its simplicity, adaptability, and strong performance, it is widely used in real-world optimization tasks. Conclusion: Gradient wolf optimization mimics wolf leadership. Excellent balance between exploration and exploitation requires minimal parameter tuning. Works well with many applications such as ML tuning, medical imaging, clustering, and scheduling. Thus, we can say that Grey Wolf optimization is robust, reliable, and easy to implement. Thank you.